this is Nathan, who is a volcanology PhD student. And Nathan, you're studying rock formations created by volcanic springs. And you've brought us to this secret location. What's so special about this location?
So this location is only one of two places that we've found so far on the Taranaki Peninsula where we get these hot spring travertine deposits. So travertine is a calcium carbonate deposit that forms when water that's rich in calcium and carbonate fuses together and precipitates this crust-looking rock on the surface. And so its essential ingredients are calcium and carbon dioxide. And that carbon dioxide dissolves into the water, and that carbon dioxide actually ultimately comes from the magma. And when it reaches the surface, it's heated up by that magma, so it's warm as well. And so it reaches the surface and it precipitates out these carbonate deposits.
Wow, I've never thought of rocks like this being associated with volcanic activity. And you've actually brought some monitoring equipment with you. Why is that?
So we're thinking that because these travertine deposits, they form because of carbon dioxide from the magma, and the water that these precipitate from is heated up from the magma. We're thinking that if preceding an eruption, magma rises to the surface, we're going to see increased carbon dioxide dissolving in the water, and we're going to see warmer water temperatures. And we're hoping to see that reflected in precipitation rates of this rock over time.
And you might be wondering why we're wearing helmets and we've got head torches. And I said before, a secret location. There's something very special about this place, Nathan.
Yeah.
We've actually got a cave down there. Tell us about it.
Keep quiet on that. So just around the corner here we have this cave deposit. So it actually looks a bit like the Waitomo caves, but on a really miniature scale. And so what's happening is we've got this travertine, this warm spring carbonate deposit, and then water percolates through this deposit and it dissolves it. And then when it reaches this cave, it precipitates out to form stalactites, which are the ones that hang from the ceiling. And then little drips will reach the bottom and they'll form stalagmites, which kind of go up towards the ceiling. And so we'll get to see some of those in a minute.
Yeah, and I'm really excited about going into the cave. Luckily we've got our waders.
Yep.
Let's go and check it out, eh?
Awesome, cool.
Okay. Wasn't that cool having a look inside a cave created by volcanic activity? Quite different to what you would expect. And Nathan, you've got a sample that you've taken from a previous field trip. Tell us about that.
So this is a cave deposit that we found in here, and it's actually a really interesting sample. So as you can see, there's this dark layer here and then this white layer here. And so in order to figure out what these different layers mean and how that relates to volcanic activity in the area, we've done some really complex chemical analysis, and we've basically vaporized the sample and analyzed the elements within it. And what we can see is that there are, at certain points, there's spikes in certain elements that we associate with volcanism at Mount Taranaki.
Right.
We're thinking that this dark layer might relate to organic matter that gets deposited, and that organic matter works its way through the cave. There's also some light layers in here that we think have lots of uranium in them, and uranium we associate with the hot spring gets even hotter, and so that could be associated with more intense volcanic activity. And we can also date these layers and get really super precise dates, so we know when when the volcano was actually erupting.
Wow, so through some pretty clever chemistry, you can get quite a history of eruptions.
Yep.
So not just a cool cave, but lots of evidence as well. Hey, thank you so much for showing us that,
My
Nathan.
pleasure, my pleasure.